Okay, so this is the problem we were doing yesterday, the last one that we didn't have time for when the bell rang. You already look amused. Okay. So this is asking us to find the tangent of the arc cosine of 2/3. So what we're going to do is we're going to look at just this part. Okay. So the arc cosine of 2/3, that means the angle whose cosine is 2/3. And I'm going to give that a name, which is u. So u is the angle whose cosine equals 2/3. And we're going to draw a picture of that. Okay, so here's just a random angle called u, and I'm going to make its cosine 2/3. So cosine is a ratio of what two sides? Good. So this is adjacent over hypotenuse. So we're going to label that on our triangle. So adjacent to that angle, we're going to put the 2, and we have the hypotenuse, which is 3. Okay, and what we want to know is the tangent of the angle whose cosine is 2/3. So there's my angle whose cosine is 2/3. I want the tangent of it. Tangent is a ratio of what two sides? Correct. So I need the opposite over adjacent of this angle. So what do I need to find? Yes. Yes to all those. So find the opposite with the Pythagorean theorem. So we're going to do 2 squared plus b squared equals 3 squared. So we have 4 plus b squared equals 9. B squared equals 5. And we do know that there's two solutions, plus or minus, but we're looking at the height at the vertical height there is just going to be a positive square root of 5. Okay, so now what is the tangent of the angle whose cosine is 2/3? You got it. Mm-hmm. Mm-hmm. No, the hypotenuse would always be positive if you flipped it over, but then the x and y depend on the direction you're going, just like in the coordinate plane. So like this would be a positive 2 and then a negative square root of 5. And then the hypotenuse would always be considered positive. And yes, you could have that happen. Most of what we're doing today is all in the first quadrant, so that's why I'm not like twisting the examples around to different quadrants. But yeah, that's what you would do. Yes, Gaddy? Just the square root of 5 over 2, because what this is this is the tangent of the angle whose cosine is 2/3. So like this is, when you say arc cosine, you're looking for an angle. Okay, so if I asked you, what's the inverse cosine of 1? What would you say? Uh-huh. No. Okay, so that's what the difference is you're looking for an angle here. So if you're talking about the unit circle, okay, so this is 1, 0, this is 0, 1. I'm just going to fill in our values. Okay, so for this one, for our x's, what's happening to our x values? Good. So what's this one? Y'all can help him, by the way. I'm doing the x values. So that's pretty far. Yeah, square root of 3 over 2. Then what? Uh-huh. Okay, and then the y values are going up, right? Because each one's getting higher. Mm-hmm. Mm-hmm. Yes. Okay, what's the first angle? And the second one? Uh-huh. And the last one. Okay. So if I ask you something like, what is, and the cosine of pi over 3? What would you say? 1/2. Okay, because the x values are giving you the cosine and the y values are giving you the sine. Okay, but if I ask you cosine inverse of 1/2, I'm asking you what angle has a cosine of 1/2. Okay, so what angle has a cosine of 1/2? Yes, but give it in radians. So pi over 3. You might have said that right. You say it one more time. Uh-huh. Yeah. Okay, so the difference here is if I say that I want the inverse cosine, I'm asking you for the angle. Okay, so inverse cosine means tell me what angle has a cosine of 1/2. Okay, so here I'm saying what's the cosine of the angle? And you're telling me that would be the ratio of the adjacent over um, hypotenuse. But on this one, if you're looking at cosine inverse, I'm giving you the cosine, you're giving me the angle. So if you go back to this problem, this is the angle whose cosine is 2/3. Okay, so the answer to this is an angle. So like if you did this on the calculator, you could get like a degree value or a radian value for that. Okay, but what I did instead of getting a value, instead of getting like how many degrees or radians this was, I just drew an angle for which that was true. Okay, so I drew an angle whose cosine was 2/3. And now what I want, so this right here is actually the u that I've drawn. Okay, the angle that I found is u. So the angle whose cosine is 2/3 is angle u. And then I want the tangent of u. So I just want that ratio of opposite over adjacent. Does that help any, Gaddy? Okay, so we actually found the tangent. We actually found that ratio. Is that all right? It's okay? All right. Okay, so now what we're going to do is a little more practice with that and then find out how we can find inverse functions, the derivative of inverse trig functions. Okay, so this is going to be one. Let me make it a little bit smaller. Okay, we're going to find the secant of the angle whose tangent is 4x. So the first thing we're going to do is we're going to draw a triangle. Okay. And this is the angle whose tangent is 4x, and that's what I'm going to draw. Okay. What do you want to name the angle whose tangent is 4x? T sounds fine. I would have gone with theta. Well, I heard T first. Okay. Could be for terrific, Michael. It doesn't have to be for Trinity. Okay. All right. So T is going to be the angle whose tangent is 4x. Okay. So we need to think about tangent. Tangent is a ratio of which two sides? Okay. So opposite of this, I'm going to put the 4x. Adjacent, any idea what I could put? 1. Perfect. Okay, so to make that a ratio, you could just do it like 4x over 1. Okay, so I need to find the secant of the angle whose tangent is 4x. And basically now I've changed this. I'm finding the secant of angle t. Okay, because I made t so that it was the angle whose tangent is 4x. Okay. So right here, when we have arctan of 4x, okay, that means the angle whose tangent is 4x. So what I did was I drew an angle, I called it t, that had a tangent of 4x. Okay, so now the angle that has a tangent of 4x is angle t that I drew. And now I want to find the secant of that. Okay, now For my reciprocal functions, I got to be honest with you, I have to go back to my original non-reciprocal functions first and then flip them. So what's the ratio for cosine? Adjacent over hypotenuse. Okay, it's all right. I don't think life will end here. Okay, so what would the secant ratio be? Yeah, you just flip it. Were you going to say 1 over that, Michael? Yeah, which would also be true, but okay. So now the secant of this would just be hypotenuse over adjacent. I haven't found hypotenuse yet, so what do I need to do? Yep. So we'll do 1 squared plus 4. Can you do it? Yeah. Did you say you wanted to do it? Oh, sorry. Yeah, so at some point when you want to do one, you can. You just have to take over the mic. Yeah. Okay. All right, so this would be 1 plus what? Thank you. Equals c squared, and then what? Mhm. Okay, so c is just going to be the square root of 1 plus 16x squared. Okay, so what would the secant then be? Yes, if you put a square root on that. Mhm. And since it's over 1, I can just leave it as the square root of 1 plus 16x squared. Okay, so the secant of the arctangent of 4x is the square root of 1 plus 16x squared. Okay, here's what I want you to do. I want you to try to draw a triangle for this one.
Alright guys, it's Michael Cornett. So, we're going to be talking about the cosine of arc cotangent of x. So, cotangent is going to be adjacent over opposite. So that's going to be x over 1. So then we need to find this. So we set it up as 1 squared plus x squared equals c squared. Solve for c, and you get square root of 1 squared plus x squared equals c. And then you can simplify that down to just 1 plus x, can't you? Nope. Alright, gonna leave it as 1 plus x squared. And there you go. Oh boy, that's an extra step. Alright, so cosine. That's gonna be, cosine is adjacent over hypotenuse. So it's going to be x over square root of 1 plus x squared. Yeah, team.